So we are doing 19.4 and 19.5 today, and one lesson's about congruence, which we will talk about in just a second, and the second lesson is about word problems. So you have two learning goals today. Your first learning goal is, by the end of today's lesson, you will be able to identify congruent figures, and your second learning goal is find the missing angle measure to solve word problems. Okay. So if two figures are congruent, that means that they have the same shape and size. Now, let's talk about the facts. There's a special symbol, a spelling word. There's a special symbol that we can draw that means that two shapes are congruent. And it's like this. It looks like this. It's an equal sign with a little squiggly thing on top. Okay, so write that down. Draw this symbol and say, that is the symbol for congruent. So when you see this symbol, you know that two shapes are congruent. Let's look at the examples first. These two, what kind of quadrilateral would you say that is? Just by looking at it. Of course, we'd have to really measure to be sure, but how would you define this kind of quadrilateral? I'm talking about these ones right here. Ruba, they look like squares. Are they also rhombuses?
Yeah.
Yeah, they sure are. Okay, so those are congruent because they have the same exact shape and size. Now let's look at these two arrows. At first glance, do they look exactly the same?
No.
They're rotated, huh? One's facing this way and one's facing up. But they are also congruent because if you measure them, you will see that they are the exact same shape and size. So even though they're facing different ways, we still call them congruent. So again, the symbol to show that they are congruent is an equal sign with a squiggly thing on top. Okay. Now let's look at these two non-examples. These are both rectangles, but do they have the exact size and shape?
No.
They have the same shape, but do they have the same size?
No.
So are they congruent?
No.
No. These two both look like stars. But are they congruent?
No.
Do they have the exact same size and shape?
No.
No. So they are not congruent. Two figures are congruent, then the corresponding parts have equal measures. So let's take a look at these figures and see if they are congruent. Number 3. Do those two shapes look like they have the same size?
No.
So are they congruent?
No.
Okay. What about number 4? Do they have the same size and shape?
Yes.
Are they congruent?
Yes.
What about number 5?
No.
You can tell really quickly, right? What about number 6?
Yes.
But it doesn't look the same. I see a point at the top. Oh, I see a point at the top here, and I see a straight line there. What do you mean? It doesn't look congruent, Noi.
They're opposite, except one of them is just upside down.
Oh, so how could I, if I had to convince myself, what could I do?
And you can trace it.
Maybe I could trace it? Okay, let me try tracing it. That's not a bad idea. So I'm going to put my paper on top. It's moving the thing. Okay, hold on. It's going crazy. Okay. Sometimes we will have word problems that we need to solve, and we can use what we know about the total number of angles in a figure to help us solve that problem. Okay, so let's review. How many total degrees are there in a triangle? If I added up the sum of all, first of all, how many angles are there in a triangle? Show me with your fingers. How many angles are there in a triangle? How many angles are there in a triangle? 1, 2, 3. And those angles will add up to, Shelly? 180 degrees. Nice. What about in a quadrilateral? No matter what kind of quadrilateral. I'm going to draw. Okay, that's not a quadrilateral. Let's try again, Miss O. Gosh. So no matter what your quadrilateral looks like, how many angles does it have? How many angles does it have? 4. 1, 2, 3, 4. And it always adds up to how many degrees? Atharva? 360 degrees. Okay? So we can use this information to help us solve word problems. So the problem says, Mark is trimming some trees in his backyard. When he goes inside for lunch, he leaves the ladder leaning against the tool shed. So let's just draw it really quick. Here's the tool shed, right? Pretend this is the tool shed. And then when he goes inside for lunch, he leaves a ladder that's leaning next to it, like that. Okay? The ladder, the side of the tool shed, and the ground form a right triangle. Oh, so it says the ladder, right? That's the ladder. The side of the tool shed and the ground, which is right here, form a
Triangle.
and what kind of triangle? And we can show it's a right triangle by drawing this little mark, right? Okay. The ladder and the tool shed form a 30-degree angle. So it says between the ladder and the tool shed form a 30-degree angle. So this angle right here must be what they're talking about, and that's 30 degrees. It says, what are the measures of the other two angles of the triangle? So how many angles do we have to give to solve this problem?
2.
It says, what are the measures of the other two angles? So they told us 30 degrees. They want to know how much the other two angles are. So how many angles do we have to give? 2. Do we already know what one of them is?
Yes.
One of them is?
90 degrees.
So we know that this one is 90 degrees. Can we use this information to find out what this one is?
Yes.
How could we do that? So because we know that the total sum of all three angles must be how much? 180 degrees, and we already know 2 of them, so we can find 180 minus 120 means the last one is 60 degrees. So to answer this question, we would write 90 degrees and 60 degrees. Yes? So what you need to do when you have these kinds of problems is you first understand what the problem is saying, just like we did. We know that the ladder forms a 30-degree angle with the tool shed, right? So here, let's draw that again. So this one's 30 degrees, right? We know that the triangle formed is a right triangle, so one angle must be 90 degrees. And we know also that the sum of the measures in a triangle, any triangle, is always 180 degrees. Okay, so the plan is we're going to add, just like Jonathan did, we're going to add the measure of the two angles we know, 90 plus 30, right, which is 120. And then subtract the sum from 180, which is what they did right here, to find the measure of the third angle. The measures of the other two angles of the triangle are 60 degrees and 90 degrees. Then we look back. This is a very important step because it helps you check your work. Did you answer the question that was asked? Did we answer the question? What are the other two angles?
Yep.
If I had only said the answer is 60 degrees, would I have answered the question?
No.
So it's important to look back and see, did you answer the question that was asked? And you can always check your work by adding the measures of the three angles. Do they total 180? 90 plus 60 plus 30, does that equal 180? And that way you know, check, your work is correct.